My name is Justin Kander. I've been researching cannabis for the past 15 years and have spoken at several conferences about medical cannabis, as well as written several books on the topic. I also have a master's degree in medical cannabis from the University of Maryland, Baltimore. I'm excited to discuss this topic today and hope that it's good for you. The endocannabinoid system is a signaling network that's present in all vertebrates. It consists of three primary components. First, there's the endocannabinoid receptors, known as CB1 and CB2. There's the endogenous cannabinoids, which is long for endocannabinoid. This includes anandamide and 2-arachidonylglycerol. And then there's also the enzymes that synthesize and degrade the endocannabinoids, allowing them to be present when they're needed and to go away when they're not. So why do we have this wide network of receptors and endocannabinoids? Why is it so important to all vertebrates, in fact? The key to the endocannabinoid system is that it's the key maintainer of homeostasis. Homeostasis is essentially a self-regulating process by which an organism maintains internal stability while adjusting to a wide variety of external conditions. And the best way to explain homeostasis is explaining the different manifestations of it. So your body temperature, neurotransmitter levels, hormone levels, energy balance, immune activity, and even cell survival and cell death are just some of the things that are controlled by the endocannabinoid system. As research shows, this system has been implicated in directly influencing a very wide variety of physiological processes and behaviors, including anxiety, appetite, nervous function, the development of new neurons and their protection, cognition, memory, pain, and even pregnancy. As you can see, this is a very important system, and supporting it is critical to human health. The two types of receptors are distributed differently throughout the body. CB1 receptors are mostly found in the central nervous system, while CB2 receptors are distributed throughout various immune cells. However, there are certain levels of both of these receptors throughout most major organs and tissues. In fact, the activation of CB1 receptors in the brain is the means by which THC imparts its psychoactive effects. Both receptors are known as G protein coupled receptors because after the receptor is activated, proteins called G proteins convey the signals from outside the cell to inside the cell, resulting in a wide variety of processes, including genetic regulation. This is a quick graphic showing the distribution of the CB1 and CB2 receptors throughout the body. As you can see here, most major organs do indeed have one or both of the cannabinoid receptor subtypes, showing their importance to the function of nearly every major organ in our bodies. The two primary endocannabinoids are anandamide and 2-AG. These are the compounds that bind to CB1 and CB2 to exert the wide variety of homeostasis maintaining effects that the endocannabinoid system is involved with. There's a lot of crossover between both of these endocannabinoids, such as exerting anti-inflammatory action. So here you can see these two studies where both anandamide and 2-AG are suppressing inflammation and exerting protective effects. The second one is quite interesting, showing how even via something like sulfur dioxide inhalation, 2-AG is able to suppress activation of immune cells and inflammatory proteins by activating both cannabinoid receptors. There are many more studies showing how important the endocannabinoid system is for limiting inflammation and the damage that often comes with it. A very critical aspect of the endocannabinoid system is its role in retrograde signaling. So normally with neurotransmission, with conventional neurotransmitters like serotonin, dopamine, or glutamate, these neurotransmitters will travel from the sending neuron or the presynaptic neuron to the postsynaptic or the receiving neuron. This is a one-way flow, whereas endocannabinoids can travel backwards from the postsynaptic neuron to the presynaptic neuron. This essentially completes the circuit of neurotransmission and controls neurotransmission from becoming out of control. So without this retrograde signaling, neurotransmission would become severely dysregulated, as is the case in a number of disorders such as anxiety and even epilepsy. Of course, the development of cancer represents an extreme deviation from homeostasis. So it makes sense that endocannabinoids would be involved in regulating the growth of cancer. And indeed, that does appear to be the case. Both anandamide and 2-AG are shown to kill or inhibit numerous types of cancer cells via the activation of both cannabinoid and other receptors. Some types of cancer cells even express higher levels of cannabinoid receptors than their healthy counterparts, possibly suggesting that the ECS acts as a defense mechanism against the development of cancer. If the cells end up expressing more levels of cannabinoid receptors, that would make them more likely to be hit by one of the endocannabinoids and then become inhibited from that activation. And there really do seem to be practical impacts to this. Among cancer patients, there are variations of some patients having higher levels of cannabinoid receptors, while others naturally having lower levels of receptors. And some studies are suggesting that those who do have higher levels are surviving better. For example, non-small cell lung cancer patients who had higher expression levels of CB1 or CB1 and CB2 had better increased survival compared to the patients with lower levels. And in another study, liver cancer patients who had high CB1 and CB2 receptor expression had better disease-free survival than patients with low expression. This makes sense because even if you're not supplementing with phytocannabinoids from the cannabis plant, if you have more cannabinoid receptors, then your endocannabinoids are going to have more targets to hit those cells, induce programmed cell death, or inhibit the development of cancer through other ways. So while CB1 and CB2 and anandamide and 2-AG are definitely the most well-characterized parts of the endocannabinoid system, there are other compounds like virodimine and 2-arachidonyl glycerol ether that are also purported to be endocannabinoids. And then there's yet further compounds like PEA and OEA that are endocannabinoid-like. And also besides CB1 and CB2, other receptors like TRPV1 have interactions with the endocannabinoid system. So overall, this is still a very early field. The CB1 receptor was only discovered in the late 80s, and then anandamide around 1992. So compared to something like the conventional nervous system, where we've known a lot about that for over 100 years or so, this is still a very early field, and there's still a lot more to learn. In summary, the endocannabinoid system consists of endocannabinoids, cannabinoid receptors, and then the associated enzymes that synthesize and degrade the endocannabinoids. The overall purpose of this system is to maintain homeostasis, allowing our internal conditions to remain stable despite external changes. And there's a wide variety of manifestations by which that homeostasis is maintained. Although the cannabinoid receptors are distributed differently throughout the body, both types help regulate homeostasis in their own ways. And then there's several references. I thank the scientists who did the hard work of discovering and elucidating the mechanisms of this system, and those who will continue to do the work further. Thank you so much, and continue to enjoy Hope Fest. Hello, my name is Justin Kander. I've been tracking the use of cannabis to treat cancer for over 15 years, and I've written extensively about this subject, as well as worked with thousands of patients. I also have a master's degree in medical cannabis science and therapeutics from the University of Maryland, Baltimore. I'm excited to discuss this topic today and hope that you learn a lot. To start with, what is FECO? It stands for full extract cannabis oil. The full extract refers to the intention of pulling out as many components as possible from the cannabis plant into the extract. These components include cannabinoids, terpenes, flavonoids, chlorophyll, waxes, and more. The primary component of FECO is definitely the cannabinoids. The concentration of cannabinoids generally ranges from between 60 to 85%, although there are exceptions and no formally agreed upon definition of what the exact percentage is. Most FECO products are predominantly THC. However, they can also be predominantly CBD or have a specified ratio of THC and CBD in it. It's just important to be aware of what is in the FECO product so you are getting what you intend to get. Aside from the primary cannabinoids of THC and CBD, there are a wide variety of other cannabinoids found in FECO. These include cannabigerol, cannabichromine, cannabinol, as well as lesser cannabinoids like tetrahydrocannabivarin and cannabidivarin. All of these work together with THC and or CBD in order to bolster their effects. The second most important class of compounds are the terpenes, as well as the modified terpenes known as terpenoids. Unlike the cannabinoids, these compounds are also present in a wide variety of other foods and herbs. They, like the other cannabinoids, they synergize with THC and CBD to enhance their effects. There's another class of compounds that are pretty understudied called flavonoids. These are probably contributing somewhat to the effects of FECO, but the impact of flavonoids on the total effect is not as well characterized. There are yet more compounds besides cannabinoids, terpenes, and flavonoids that might be helping, including the ketones. The role of the other compounds like chlorophyll and waxes is also unclear. More research is needed to determine what the impact of these constituents is to the overall effect of FECO. And it's quite likely that some constituents are inert and aren't producing any therapeutic benefit. The process for producing FECO is relatively simple, although there is a lot of nuance. The process basically comes down to soaking cannabis flower in ethanol for at least several hours, straining the solution to remove the cannabis flower, and then evaporating out the ethanol with heat, leaving the pure extract with nothing else diluting it. There are other solvents that can be used to make FECO-like products, including butane and supercritical carbon dioxide. For now, it does appear that ethanol is the superior solvent, as the nature of its chemical structure allows it to pull out a wider variety of compounds than the other solvents. Eventually, it will be great to see research that compares the efficacies of FECO products derived from different solvents, but as of now, it definitely appears that ethanol is the best, and I personally believe it's going to continue that way. There are many other types of high potency extracts besides FECO on the market that are even more popular by purchase amounts. These other types of extracts are mainly intended for dabbing, which is a form of smoking, and they go by names like shatter and butter. They tend to be higher in the total THC levels than FECO, often 75 to 90% or more. Most of these types of products are made with butane, and it's a relatively fast process that involves running the butane over the flower and then immediately collecting the extract that comes out. FECO takes a lot more time to make, and the cannabis is often soaked for a much longer period of time, up to 24 to 48 hours. And so here's the trade-off. FECO will have lower levels of THC than the dabbing type products, but it also has a wider spectrum of other compounds that is contributing to the healing. It will be interesting to see research comparing the efficacy of short and long-term FECO products in the future, but for now it does appear that longer soaks, as long as you're getting reasonable cannabinoid levels of at least 60%, is effective and it's a good trade-off. So the extracts intended for smoking are not preheated. They mainly contain THCA, not THC. THCA is the compound that the cannabis plant actually produces, and it only turns to THCA, and THCA only turns to THC after being subjected to heat. Since FECO is normally consumed and not smoked, the THC must be converted to THC prior to the FECO being sold. Preheating the starting cannabis in an oven is one great method. But the dabbing extracts do not need to be preheated because they get activated at the time of consumption. THC cannot activate receptors and THC can. That is their primary difference. While THCA does have medical properties and it's very promising, the vast majority of patient experience concerns the use of THC. And there's no doubt that's what if you're searching for a THC rich FECO, you definitely want it to be mainly THC and not THCA. As for how they're sold, you can usually identify FECO because it comes in oral syringes, as seen below, whereas the extracts intended for smoking are usually sold in small circular jars. You can also see that the dabbing type extract is brighter than the FECO product, and that's because FECO contains higher levels of chlorophyll and waxes, whereas those compounds are very limited in the dabbing type extracts. The primary advantage of the FECO product is being able to take high doses of cannabinoids with a small volume of product. This is important for patients when they're getting up to the high levels of cannabinoids that evidence suggests are needed to potentially treat cancer. And this range is about 200 to 800 milligrams per day. The potencies of edibles and infused oils are usually too low to achieve these doses. And that's how medical cannabis was often used before FECO, like for treating the symptoms of cancer, either using edibles, infused oils, or smoking has shown to be very effective at treating symptoms like nausea and pain. But it's only apparently through the consistent high doses of cannabinoids that can be delivered with FECO, or at the very least, very high potency infused oils. That's where the anti-cancer effects kick in. So just running through a quick example, if you wanted to take 300 milligrams of THC and you had a infused oil that was 30 milligrams for every milliliter, you would need 10 milliliters of that oil to get 300 milligrams. So that's quite a lot of liquid to ingest and often unpleasant for patients. Whereas if you had a FECO that was 700 milligrams for every gram, it would only take about 0.43 grams to reach that same dose. 0.43 grams is a lot easier to consume than 10 milliliters, and so it makes it a lot easier for patients to get these high doses in a very convenient way. Another possible advantage is that FECO contains a greater variety and higher concentration of other compounds like the terpenes and flavonoids that contributes to efficacy. Therefore, getting 100 milligrams THC via an infused oil may not be as therapeutic as the same dose delivered via FECO, because FECO is going to also have other cannabinoids and terpenes that help that THC do its job better. Many people are probably familiar with the term of RSO, which stands for Rick Simpson oil. The name ultimately comes from a man named Rick Simpson, who healed his own skin cancer and then subsequently treated many other patients with his own homemade version of FECO. His original extract was made with naphtha, a toxic solvent, and thankfully this is not used anymore. But that's how it all started. And so in practice, in modern times, RSO is FECO. They're both highly concentrated, decarboxylated extracts that come in oral syringes. That's the key definition of what a FECO product is. It does seem more likely that a product labeled as RSO is more likely to be extracted with butane, CO2, or other petroleum-derived solvents, and FECO is more likely to be extracted with ethanol. However, there can be alcohol-extracted RSOs and CO2 extracted FECOs. It really just depends on what the person producing the medicine calls it. But for now, as stated, it does appear that alcohol-derived extracts are more effective because of the broader spectrum of compounds that are being pulled out. So regardless of what the product is called or what the solvent was used to extract, or what solvent was used to extract with, the most important thing is that you're using products that are lab tested, because this lets you know exactly what's in the product. After lab testing, a certificate of analysis will be produced that lists the exact cannabinoids and terpenes present in the extract, what their levels are, as well as the presence and levels of possible contaminants like residual solvent, bacteria or fungi, pesticides, and heavy metals. So with lab testing, you know what are the therapeutic compounds present in the FECO, and is there a lack of contaminants that could impair healing or cause problems of their own. So here's an example of a lab result. So this is a THC-rich FECO type product, and as you can see, it is predominantly THC. About 73.62% of the extract is THC, and then there's smaller amounts of other cannabinoids, about 2.4% CBG, 2.1% CBD, 0.5% THCV, and 1.25% CBN. So you see exactly what's in there. And then where the terpenes, this has a decent level of 0.41%, with about 6 different terpenes, including common ones like limonene, linalool, and myrcene. So this is a decently good extract, and you're getting the synergy there. Rather than just only having THC, you have other cannabinoids and numerous terpenes that are all working together to support THC's action, whatever you're going for, pain, inflammation, cancer. It's always good to have the full spectrum of compounds. And then this is an example of the possible contaminants. So in this one, you can see that there are no pesticides or microbes at all, which is good. For the residual solvent, for some reason with this extract, which is not associated with us, by the way, but there was a little bit of acetone and methanol present for some reason. But this was not a problem. The limit for acetone is 3,100 parts per million. There's only 21 here. Methanol parts per million is 12 when the limit is 400. So if there are small amounts of these other residual solvents, if they're well below the limits, then they are safe. The ethanol, as you can see here, is much higher, about 1,800 parts per million of ethanol. This is still below the limit of 5,000, and actually, it is good to see a little bit of residual ethanol in the extracts, because if you see 0, normally the product was overheated and you've lost excessive terpenes. There's a balance between heating to remove the solvent and then terpene loss, so that has to be balanced. So you do want to see a little bit of that residual, usually. If it was above 5,000, that might get a little problematic. But yeah, that's essentially FECO, a full extract of the cannabis plant with no significant remaining solvent and nothing else diluting it, which is what enables it to have such a high percentage of cannabinoids, usually in the 60 to 85% range, as well as at least 0.25 to 1% terpenes. The overall process is simple, of soaking cannabis in ethanol, filtering out the remaining plant matter, and then evaporating out the solvent to leave the pure extract. And as long as it's lab tested, then you'll know exactly what cannabinoids and terpenes are present, and that it doesn't have any excessive residual solvent, pesticides, or microbiological contaminants. And the example didn't have heavy metals, but that is also an emerging class of testing that's coming. So this is the heart of FECO. I hope that you've learned a lot from this presentation and that you continue to enjoy Hope Fest. Hello, my name is Justin Kander. I've been tracking the use of cannabis to treat cancer and other conditions for over 15 years and written several books about cannabis, as well as spoken at conferences around the world. I also have a master's degree in medical cannabis from the University of Maryland, Baltimore. I'm excited today to talk to you about terpenes. Terpenes are very important compounds produced by thousands of plants, and in fact are the largest and most diverse group of naturally occurring compounds occurring in nature. Their basic building block is the isoprene unit, a molecule composed of 5 carbon atoms and 8 hydrogen atoms. Terpenes contain multiple isoprene units, and they're characterized based on how many units are present. For example, monoterpenes contain 2 units, sesquiterpenes contain 3 units, and so on. The vast majority of terpenes that are present in cannabis are either monoterpenes or sesquiterpenes. Isoprene itself, interestingly enough, is not considered a terpene. Terpenes are made by plants to help with their survival and have several functions, including defending against consumption by predators, protecting against heat, and conducting cell signaling. They also contribute substantially to the fragrance and taste of many plants, as well as their colors. There's over 40,000 chemicals that are considered terpenes. The terms terpenes and terpenoids are often used interchangeably, and I'm sure many people here have heard both terms used. While they are used interchangeably, there is one major difference between them. Terpenoids have the presence of oxygen, as well as sometimes other chemical changes. So they're essentially modified terpenes. In practice, when discussing terpenes, that term will inherently include both terpenes and terpenoids. And indeed, cannabis does have both of these classes of compounds. Cannabis overall contains well over 500 compounds and likely many more. At least over 150 of these compounds have been identified as terpenes. Although there is a very wide spectrum of terpenes in cannabis, there's only a relative few that are routinely tested for in cannabis products through laboratory analysis. Because there are so many and only a few are tested for, even if a lab test does only show the presence of a few terpenes, it's almost certain that many others are present. No one strain, or chemovar, essentially short for chemical variety, of cannabis contains all of the terpenes that have been identified. Different types of cannabis can have completely different terpene profiles. Here's a list of some of the most common terpenes in cannabis. Really, it's the first 7 here: beta-caryophyllene, D-limonene, alpha-pinene, beta-pinene, linalool, myrcene, and alpha-humulene that appear to be the most dominant and show up the most prevalently. Beta-caryophyllene and myrcene in particular are especially prevalent in most strains of cannabis. However, there's a wide variety of other terpenes, including lesser ones like beta-ocimene, terpinolene, and 3-carene that contribute their own unique therapeutic benefits. Many terpenes, or most terpenes, are found in a wide variety of other plants. For example, beta-caryophyllene is a major constituent of black pepper, and linalool is one of the primary components of lavender that is associated with lavender's ability to reduce anxiety. It's also important to distinguish between cannabis-derived terpenes and botanically derived terpenes. Any natural extract or infusion of cannabis is naturally only going to contain the cannabis-derived terpenes. However, there are many manufacturers out there who add terpenes to their products, either using mixes of cannabis-derived terpenes or terpenes derived from other plants, which are usually referred to as botanically derived terpenes. It is possible to purchase full-spectrum cannabis-derived terpene products that don't have any cannabinoids. However, they are usually more expensive than BDT products, while also including a wider variety of terpenes to justify that added expense. In practice, it appears that CDTs and BDTs are usually added to vaporizer cartridges to intensify the flavors. They are very rarely added to FECO type products, and I'm not aware of actually any cases where extra sources of terpenes are added to FECO. In terms of an individual terpene, there's no difference between a specific CDT or BDT. For example, myrcene from cannabis is the same molecule with the same properties as myrcene from hops. In general, the CDTs are going to have a wider variety of terpenes present, which is why some people like to see CDTs used rather than BDTs. It's also interesting to point out that several terpenes do have the exact same chemical formula, but exert different effects. For example, limonene and myrcene both have the chemical formula C10H16, yet the former tends to be energizing and the latter sedating. It's also interesting to note that THC and CBD also have the same chemical formula, C21H30O2. Despite that same formula, THC can activate cannabinoid receptors and lead to the characteristic high, whereas CBD does not activate cannabinoid receptors and does not lead to the characteristic high. The varying effects are ultimately due to these molecules having different shapes, and that impacts how they can interact with their biological targets, like receptors or enzymes. The shape of THC allows it to bind with CB1 receptors, whereas the shape of CBD, despite that same chemical formula, does not allow it to bind in the same way as THC to the CB1 receptor. Now to the good stuff, the medical benefits of terpenes. There are many, many studies showing how terpenes have a wide variety of effects, from fighting parasites and viruses to helping with depression, exerting anti-inflammatory and antioxidant effects, possibly helping with epilepsy through anticonvulsive effects, as well as protecting neurons. And it's good to show some specific examples of the terpenes that were mentioned before and some benefits. For example, limonene has been shown to exert antidepressant effects by fighting neuroinflammation. Beta-myrcene has been shown to limit colon inflammation, and beta-caryophyllene has been shown to kill colorectal cancer cells. Even just inhaling linalool has been shown to induce anti-anxiety effects, while ocimene may be able to fight the parasite leishmania. Beta-pinene might prove to be useful for helping with diabetes by controlling blood sugar and through fighting inflammation, whereas alpha-humulene could be good for fighting drug-resistant bacteria by disrupting the biofilms that bacteria use to become resistant to conventional treatments. Interestingly, there's not too much research on 3-carene, but it might have use being applied to meat products to fight bacteria and prevent their spoilage. And it's likely if it can fight that bacteria, it has other useful antibacterial properties. There's a lot more research that needs to be done on terpenes, but what does exist is definitely very promising. There is a lot of theory about the ability of cannabinoids and terpenes to work together to enhance each other's medical benefits. Areas of potential synergy include the treatment of pain, anxiety, cancer, and a variety of infections. So for example, if someone took 10 milligrams of THC alone, it might reduce pain or inflammation to some extent, but likely not as much as using 10 milligrams of THC combined with 1 milligrams of a total terpene mix. It doesn't appear that you need much terpenes to enhance the effects of cannabis, although using multiple terpenes rather than just one appears to be more effective. Indeed, the overall evidence and report suggest that using cannabis products with a wide variety of terpenes may increase the therapeutic benefits. There are some reports of patients responding poorly to certain terpenes, such as guaiol and terpinolene. However, not everyone responds to certain terpenes in the same way, and even a terpene which may induce anxiety when combined with certain other terpenes might not cause anxiety when combined with other terpenes. Therefore, ultimately, what's most important is knowing the terpene profiles of the cannabis products you're using. That way, if you have a positive or negative reaction, you can know what terpenes were associated with that experience. It's also critical to note that regardless of the terpene profile, taking too much THC is usually going to cause anxiety, even if it's taken combined with high quantities of purely anti-anxiety terpenes. The anxiety-inducing effects of THC at those very high levels is going to overpower it. It also appears that the effects of cannabis medicine could be improved by consuming other terpene-rich plants alongside it. By ingesting a wide variety of fruits, vegetables, herbs, and spices, people can ingest a broad spectrum of terpenes in high quantities and thus contribute to the synergy that could be obtained by combining cannabinoids and terpenes. Essential oils are especially powerful tools because they're predominantly composed of terpenes. They can be absorbed either using diffusers or certain food-grade essential oils can be ingested, but that special care must be taken if essential oils are going to be directly ingested. In summary, terpenes are components of thousands of plants, and they're made for the purpose of improving plant survival. Thankfully, They don't help just the plants, and research is indicating that they also have medical benefits in humans and can work together with cannabinoids to enhance their effects. By knowing the terpene profiles of the products you use, you can find which are most effective and which might not be as agreeable to you. And then here are several of the references that were used to put this presentation together. And thank you to the scientists who did the legwork in discovering these incredible properties. Thank you so much, and continue to enjoy Hope Fest. Hello, my name is Justin Kander. I've been tracking the use of cannabis to treat cancer for over 15 years and written extensively on the subject, as well as spoken at several conferences. I'm excited today to talk to you about apoptosis, the most powerful anti-cancer mechanism of cannabis medicine. So what is apoptosis? The term means programmed cell death, which is a natural process that cells undergo for the purpose of ensuring survival of the entire organism. When cells become old or damaged, apoptosis is the body's natural way of removing them in an efficient manner without damaging other cells. Too little or too much apoptosis is a factor in many diseases, including cancer, where too little apoptosis leads to uncontrolled tumor growth. The programmed nature of apoptosis refers to how it is genetically encoded, and genetic malfunctions may interfere with the normal apoptosis process. Ultimately, restoring apoptosis is critical for effectively treating cancer, as this is what causes the cells to disappear. Another form of cell death is necrosis, which is an uncontrolled form of death. In this case, the cells explode, releasing their cellular contents into the surrounding area and causing a damaging inflammatory reaction. Apoptosis is clearly a superior form of cell death because it's controlled and regulated and normally does not cause inflammation. In addition, the apoptotic bodies that form after apoptosis can be digested easily by immune cells or even absorbed and recycled by neighboring cells, allowing their contents to be reused by the body. This is a visual example of how apoptosis and necrosis differ. As you can see here with apoptosis, the cell neatly breaks down into those small apoptotic bodies, and that is what gets absorbed by the cells or by neighboring cells or immune cells. Whereas with necrosis, the cell explodes and then the body has to deal with all those contents just swimming around, and that's where the inflammation happens. So how does cannabis play into all this? Dozens have shown how numerous components of the cannabis plant can induce apoptosis in many types of cancer cells. The most well-studied of these components are the cannabinoids THC and CBD. However, there are many other cannabinoids like CBG, CBC, and CBN that have also been shown to have apoptosis-inducing abilities. Furthermore, the terpenes in cannabis, which give it its smell and help synergize with the cannabinoids to direct their effects, can also induce apoptosis in some cancer cells. As an example, here are many studies showing how THC can kill a wide variety of cancer cells. Many of these you probably recognize and are relatively common, but even rare, less well-known cancers like cholangiocarcinoma and rhabdomyosarcoma have also been shown to be susceptible to THC. And practically, it's also being shown to work in animals. In this study, both THC and a synthetic cannabinoid called JWH133 were administered to mice, and their tumor growth was observed to be far smaller than the untreated mice. Furthermore, both cannabinoids were able to reduce the total number of tumors per animal as well, in addition to shrinking the overall volume. In many cases, these synthetic cannabinoids are used to identify the mechanisms by which cannabinoids are exerting their anti-cancer effects, And this helps show that THC is causing the cell death by activating cannabinoid receptors. Like THC, CBD has also been shown to induce programmed cell death in a wide variety of cancer cells. There's substantial crossover between what cells are susceptible to both THC and CBD, and this is why it is usually best to use some level of both THC and CBD in cancer treatment. I'll just linger here for a moment to give time to appreciate the wide variety of cells that CBD can indeed kill. And just like THC, CBD is also being shown to work in animals, in this case, shrinking a lung tumor. Not going to be getting into every single cannabinoid, but I do think it is worth mentioning that CBG is also showing promise. CBG is a special cannabinoid because it's the mother cannabinoid from which all other cannabinoids are derived from via enzymatic processes. While it's not as well researched as THC or CBD, the initial studies are promising. And then there's a few of the cancer types that CBG has been shown to work for. So how do they actually work? As noted, a lot of the times cannabinoids are binding to cannabinoid receptors on the surface of cancer cells and then causing their apoptosis. Specifically, these are CB1 and CB2 receptors. Sometimes CB1 is implicated, sometimes CB2, and sometimes other receptors such as PPAR gamma, TRPV1, TRPV2, and TRPM8 are also involved. Therefore, cannabinoid receptors don't necessarily need to be present for cannabinoids to potentially exert an anti-cancer effect. There's other receptors like GPR55 and PPAR alpha that are emerging targets of interest, but these have the least research behind them currently. This is just a quick chart to show some examples of how cannabinoids are working against different types of cancers. For example, with CB2 receptors, CBD has been shown to kill leukemia cells through that mechanism, while THC works through liver and pancreatic cancer cells, and TRPV2 receptors and TRPV1 is largely a mechanism from CBD and kills a wide variety of cancer cells through those. As more research is conducted, it's certain that the lesser known receptors are going to continue to be shown to play a role in fighting the cancers. This is definitely the least important to spend a lot of time on, but it is good to know about the downstream effects because the activation of the receptors is just the first step in a long path that leads to apoptosis. Two of the most common things that come up are the inactivation of survival pathways like MAPK and AKT, as well as increasing cellular stress through reactive oxygen species. These are some of the mechanisms that across many types of cancer cells are leading to the actual apoptosis after the activation of the aforementioned receptors. Knowing this level of detail is not relevant for practically treating cancer with cannabis, but it is certainly interesting. What really brings this all together is that it's not just the cannabinoids from the cannabis plant that are causing apoptosis, but also our own self-made endocannabinoids. All mammals and vertebrates, in fact, produce endocannabinoids to exert a wide variety of biological functions, including apparently naturally protecting against the development of cancer, has been shown to induce apoptosis in many cancer cells, largely through CB1 and TRPV1 activation. There's also evidence showing that the other main endocannabinoid, 2-AG, also has anti-cancer effects. And indeed, it's not just the cannabinoids, but also the terpenes in cannabis that have also been shown to kill a wide variety of cancer cells. Beta-caryophyllene, which is also found in black pepper, has been shown to kill colorectal cancer cells. Linalool, which is also found in lavender, has been shown to kill prostate cancer cells. And then there's a few other examples. There's a lot of terpenes that have not been well explored for their anti-cancer activity, but with further research, I have no doubt that the anti-cancer properties of the terpenes may prove to be nearly as important as the cannabinoids. And this is why it's important to use full spectrum cannabis rather than just THC or CBD isolates. When using an isolate, you're only tapping into one potential set of mechanisms from one compound, whereas with full spectrum cannabis, with many cannabinoids and many terpenes, you're gaining access to numerous compounds that can kill cancer cells through similar mechanisms. Furthermore, if a particular cancer might be resistant to one cannabinoid or one terpene, it may be just susceptible to a different mix. So by having this full spectrum mix, you're getting the widest variety of compounds that may induce apoptosis and giving the greatest chances of success. In summary, both cannabinoids and terpenes are shown to induce programmed cell death, known as apoptosis, in a wide variety of cancer cells. Moreover, our naturally produced endocannabinoids have also been shown to induce apoptosis through similar mechanisms as the plant cannabinoids. And it's this reality that makes it far more likely that phytocannabinoids would work in humans, and that's exactly what we are indeed seeing in practice. Also in practice, it appears that using full spectrum cannabis is the best way to maximize the achievement of apoptosis, and more research will certainly back that up as being the superior option over isolates. Thank you so much for listening, and I hope that you learned a lot.